Hi, this is my ECE 2001 project for Project 2. My name is Maria Tuxbury, and I was partnered with Robert Massadea and Adeline Richard for this project. Basically, we had a receiver and a transmitter, and within this project, we had to shoot a laser beam, and it got us to get a certain sound coming out of a speaker, and it was a truly amazing experience. Here is my board number to clarify that my work is all my own, and you will see on the next picture that my board number can also be seen within it. So here I have my completed board, and basically within my completed board, I made a couple decisions. Basically, my aux and microphone circuits are set up very similarly, and I decided to do this because the microphone circuit that I had from Project 1 was already working very well. My microphone was very sensitive, very successful in that aspect, and so I chose to keep that. And when I used it with the aux, it also had a similar progress, and so I ended up keeping it the same for both of those, and that worked out very well for the project. I also used the 5 amplifiers that were suggested during lecture in order to amplify the sound to my speaker, and that was very useful. And I also chose something for my solar cell. I chose to have, because we had different options for the way that our laser was entering the circuit. So I chose a solar cell. We had a couple different options, photodiodes and photoresistors that we had used in a previous project, but I chose to go with the solar cell because it maximized the amount of surface area that the laser was able to point at, therefore making it easier for the light to be retained and the power to be retained so that the speaker could work optimally. For the indicators of my circuit, I chose to use the same ones that I had for my microphone circuit, since those already worked well with all 8 lights, and when I added the aux circuit, they worked as well. I set up with the same resistors for my speaker circuit, same setup for those lights, and it worked as well, so that was fantastic and really lucky for me. So I just wanted to show there how my LEDs were working for the sound, and as you can see, they worked out very well. But so here I have my LT Spice for my receiver circuit, and basically I have my LEDs set up to the top right, my microphone used to the top left, the aux cord on the bottom, and my laser circuit in the middle. If you're thinking both of those aren't supposed to be connected to the laser at the same time, basically I would just cut off one wire and then test it, then cut off the other wire, reconnect the other wire, and test it again in order to get my measurements. Here I have my LT Spice for the speaker circuit, which was the transmitter of the circuit. Basically, you can see to the right, once again, I have all my LEDs set up. Same process as I had from Project 1, those LEDs being set up. The solar cell circuit is to the left. I have all my amplifiers set up right in a row, all those 5, as you can see down the center. And at the very bottom, I have my speaker where the sound would be coming out of. Basically, this LT Spice setup, I was pretty confident in it, but there may have been a few slip-ups somewhere with the sign processes, but yeah. Here are my results. You can see for my microphone laser, everything was oscillating, so I got sine waves between -80 to 80. For the laser, I got -645 to -545. And then I also got for my solar cell and my speaker -50 to 50 millivolts and 745.4 to 661.3 microvolts. And then I have the pictures right here that you can see. This was the demonstration that was shown when I put it into LT Spice. So you can see those sine waves in action showing the amplitude as these voltages goes up and down. I have similar also for the aux speaker. So for the aux cord, I basically had to do those same measurements again, and everything ended up playing the exact same way. The only difference was that the aux cord was -50 to +50 millivolts instead of 80, and those could due to just the differences of how the aux cord was built. Basically, then I also went to show the demonstrations from LT Spice here as well. Got the same thing for the solar cell and speaker side, and there was only small differences with the aux cord. Here I have the demonstrations of the real-life oscillations. See for yourself with the voltmeter and oscillator. So within the oscilloscope, you saw for the first one that was using the microphone. Due to time limits, I wasn't able to get as many measurements as I'd like. but using the microphone, I got the fluctuations that you see here on the oscilloscope, and I also used the voltmeter to double check, and I got about 7 millivolts with the voltmeter on average, which makes sense because that fits into my expected range that I was going to get there. Then for the aux cord, I got about 10 millivolts, so it was a little bit higher. The oscillations you could also see in the video, and when I double check with the voltmeter, that's what I'm saying. I got about 10 millivolts. And also with both of those, I got about 20 millivolts coming out of the speaker, but those fluctuations could also be seen on the oscilloscope. And yeah. So while I did record with 2 different partners, I'm going to show you the results that I got from my working with Robert, and these will have 2 videos from my board and 2 videos from his board.
Hello. Welcome to ECE 2001, Project 2. Took so long. Thank you and good night.
Thank you so much for watching. I hope you enjoyed this project video because I really enjoyed making it.